ஒரு புதுசு இருந்துச்சு காலில் போன வைக்க வச்சு முடிவு கொண்டு வைக்கிற கூட
Hello.
Hello. We are facing some technical difficulties. We'll be soon getting underway with the session as soon as we deal with the difficulties. Okay. So please have patience for some time. Okay.
Hello guys, can you hear me? I would like
Yes,
to confirm. Okay, so guys, here Shmalyo, who is going to take our session today. He's an expert on malware development, and I guess he has taken a class before and also. So off to you, Shmalyo.
Hello everyone. Is my audio coming? Hello everyone. Is the audio coming?
Yes, sir. Yes.
Okay. So this is our second, I guess, final class on malware development. In the previous class, I discussed a very interesting use case of developing hybrid malwares. It's an extension to the different kinds of malwares out there. Today, it's gonna be some application and app-driven courses. Like I'm going to use some applications which are famous as malwares, and I'm going to introduce you to some programming techniques with which you can code your own malwares in a very simple fashion. And I'm going to introduce you to some forms of coding malwares as such. So, how many of you are proficient in the C language? Hello?
Yes, sir.
How many of you are proficient in C language? C.
Sir, C++ is fine.
Okay, C++ would do. Basic
Yeah, yeah,
concepts would say so.
yeah. Basics I know.
Okay. So when you're going to develop malwares, you're going to essentially write most of it in C or C++, whichever you prefer. I'm going to use C for the course. And first, I'll not start right away with malware development. As I got from the previous course that many of you had used stuff like MSF Venom or Metasploit to generate shells or gain access over machines. Am I right? You have used Metasploit, right? Or do I need to go on with Metasploit?
Yes,
Hello?
sir.
Yes,
Metasploit.
sir. Yes,
Yeah,
Metasploit.
so you use Metasploit, right? Like,
Yes, yes, sir.
so yeah. Or if you have not used Metasploit, even if for somebody here out here, there are a ton of videos or courses which are available on Metasploit or very such uh, you know open source and widely used malware or like malware command frameworks, which you could get an idea as to what kinds of exploits or what kind of capabilities these usually have. Today I'm not going to cover stuff like Metasploit. I'm going to cover some lesser known command and control frameworks, but these frameworks would rather give you a better insight into the system of development. I'm going to introduce you to some lesser known post exploitation tools. I'm not going to the I'm going not going through the process to set up these tools essentially, because most of the tools have either some documentation on the internet, they have some wiki pages on the internet which has installation guides, and usually the installation takes long, so I'm not going to demonstrate that on screen right now. But yeah, getting these installed is not at all, it's not at all some it's not at all a tough job. You can get this installed uh, very fast on your system, and the requirements for these malwares are not essentially something that you would not have like ready on your Linux or Windows distribution. Some of them, yeah, can be run on Windows machines. I myself am running some malwares or some command frameworks from a Windows machine. There's no need to get into the understanding that only Linux can provide such capabilities. Um, and yeah, most of them is going to run on Linux. I use Ubuntu for the process. I recommend using Ubuntu rather than Kali in this regard, because Ubuntu has a lot more supporting repositories and supporting files which are needed usually for these cases. But I guess if you're using some other distribution where the packet manager does not support supporting like libraries and all, you can build them from source, right? Mm,
Yes, sir.
okay. Okay, so we're going to discuss about. I'm going to show you rather a command and control net framework, which is a bit different from Metasploit. I mean, uh, how is it different? I'd show you how is it different, and essentially tell you what's the current kind of like current style of. Okay, I'll tell you what's the current style of C2 frameworks out there. It's not what you essentially see on the internet a whole lot of the time, because I'll explain why, and I'll also explain why these new kinds of frameworks have evolved and what kind of capabilities they do come with, and how they are very similar also to some of the traditional C2 frameworks you perhaps have used, like Metasploit. So, okay, I'm going to switch to my I'm going to switch to my virtual machine, and then I'm going to share a screen with you. Let me see. Can you see my screen, right? Can you see
Yes, Maluda. Perfect.
my Ubuntu screen is visible? Okay. So the malware that I am using over here,
Uh,
the
Shumaluda, it's still dark. Is this some? Is there something on the screen? It's completely black.
Yes.
Uh, you can see an Ubuntu framework, right? You can see an
No.
Ubuntu.
No, it's completely dark.
Okay. Um, but I'm sharing the screen from. Let me try again. As now, right, my screen is visible right now.
No, not yet.
No, sir.
No, sir. Still the same black screen.
Okay, okay. But I'm running stuff on my virtual machine. I need to run stuff from my virtual machine. How is there a problem on sharing screen on Microsoft Teams if it's a virtual machine it's running? Because I need to show my VM during this development. Like, is like there a problem?
No, I guess.
Uh, okay, let me try. Let me try once. Right now, is it visible?
Yes, sir. It's visible.
Yes, sir.
It's visible, right?
Yes.
Yes, sir.
You can see a
Yes,
Linux.
sir.
You can see a Ubuntu like desktop, right?
Yes, sir. Yes,
Yes,
Okay.
sir.
sir. Yes, sir.
Okay, so right now we're going to discuss this very lesser known malware. It's called red mimicry. It's a command and control framework, and what's essentially good about this is that this has a much elegant architecture than Metasploit and everything. And what's the first thing that's kind of striking over here? It's the fact that here we don't have exactly a command line terminal, right? In Metasploit or in any other very traditional post-exploitation tools that you essentially have, you have a command line terminal on which you uh, like set tasks for your uh, victims. Here we do not have essentially a command line agent. Instead, we have a web panel, and that's something new that's been around for quite a while for these kind of C2 frameworks. Obviously, red mimicry is not something that's available for free. You have to request access to these kinds of stuff, and this is also in the beta stage, so it's not a very well developed thing. But this kind of thing is coming around lately. It's coming around in the market where you do not essentially have a CLI to command your victims or to execute the attacks. Instead, you have a web panel. And what's the advantage of these kinds of things is like you don't need to have access over your attacking machine directly. Since these are web panels, and if you can forward the ports correctly, you can make these visible from other like network connections. You can have a server which works as your attacking machine for your victims, which works as your team server. You can buy this kind of servers on, say, Amazon Web Services or like other kinds of such places where you have hostings. You can buy a hosting essentially, and then you can run your C2 framework on these, not have a visual access to these essentially, and then you can, forward the ports or configure the ports in such a way that you can log in to these C2 frameworks even if you do not have a direct access or direct visual access to these machines. So here your attacking machine could be more powerful. It could essentially change. It could be a reason for stealth. You could use these kinds of attacks on very for to compromise stuff that is of a pretty high stake. You'd need stealth. You'd not want essentially that your attack is traced back to you. So there are a lot of advantages of running some command line, there's a running some web panel rather over some command line which is directly running on the machine. Or they provide a lot of visual access too, I guess. So first let's see an architecture of this Okay, so is this diagram visible?
Yes, sir.
Is
Yes,
this
sir.
this diagram is visible, right? Okay.
Yeah.
So, how many of you have had some experience in developing stuff on Windows using DLLs, batch files, EXEs, essentially like developing Windows applications in C, C++, something to do with like coding Windows applications. Like, uh, any experience with what's a DLL or like what's a batch file? I guess batch file you might know. What's a DLL? What's a DLL?
No idea.
Uh, you you work on Windows architectures, right? So see, whenever you're going to develop malware, essentially, you're going to have to understand Windows architectures. If you are not even working on a Windows machine, most victims that you will be targeting are using Windows machines, right? You as an attacker, you're using some Linux distribution, Red Hat, Kali, but your victim, your target, is essentially using a Windows machine, right? So if you do not know stuff about the Windows environment, about the Windows running environment, you do not essentially understand how malwares are developed or they run um, on these kinds of circumstances, like these kinds of uh, like s- I'll try to explain what's going on over here. You have a red mimicry server, and currently my 1.2 virtual machine is acting as the red mimicry server, which is right over here. And then you have assembly agent.exe file, which this red mimicry would generate, which would connect back to my server or call back to my server, and then I can use my server to command this, and I'll be using this web panel as an interactive command for my agents. And one thing about red mimicry is that you can see this, there's a multi-process uh, flow in this kind of an architecture where each part connects, not temp.bat does not connect, but these four all have callbacks to the red mimicry server. So this is a stage exploit, like there are four stages of a single machine being exploited. uh, how many of you have some experience in CTFs or capture the flag events, or have seen some recording of CTFs, or are interested in stuff like CTF competitions? Like any guesses? Like, anything? Have you ever worked with something like capture the flag CTF competitions?
Yes,
Okay,
sir.
Yes,
so
sir.
yeah, go. You worked with CTFs, right?
Yes, sir.
So with CTFs, you have this kind of a step-by-step process where you first gain a user access or a user shell on the machine, and then you escalate privileges to gain an admin access on the machine, right?
Yes, sir.
There are flags like there's a user flag, there's a root flag.
Yes.
So here also there's a similar kind of process happening. Once you deploy your agent on the victim's machine, it has user access, and slowly it it injects the code into um, process following or other kinds of techniques which it uses to escalate privileges or stay evaded from antiviruses, and then it escalates its privilege up the layers to gain admin access and persistence over the machine. So uh, uh, if you not understand some architectures or some Windows, um, like essentially Windows environments, if you are into malware development or if you are interested in malware development, I would seriously recommend going through some Windows development courses, or like some ideas of what DLLs are, or how to develop with DLLs, and what are the important DLLs in Windows, and what are the vulnerabilities in the Windows operating system. How many of you have read about vulnerabilities in Windows operating systems? Like most of the CTFs that you have done, I guess, are on Linux machines, right?
Yes, sir.
Yeah,
Yes, sir.
there are Linux machines. They are exploits which are usually related to the web services that are running on these machines, or some kind of vulnerability on Linux machines. How many of you have done Windows machine based CTFs? I guess nobody. So see, essentially malware development can be understood as a Windows exploitation. Like mostly what we deal with are Windows architecture exploitations. Okay, we are not going to hack Linux machines directly in our first malware development attempts. Mostly, it's not because it's unhackable. It's mostly because um, Linux machines are not the targets which you would cater to in a like environment of attack. Mostly your targets won't be on Linux machines, your targets will be on Windows machines. And I guess with CTFs you have a good understanding of Linux vulnerabilities or web service vulnerabilities. If you are willing to uh, develop malwares, you should also get a good idea of Windows vulnerabilities. And what red mimicry does, it red mimicry simulates very famous binary called win this called it's called WinNTI. It's a 2015 binary. It was a famous, it exploited a famous vulnerability in Windows. And this emulates that virus essentially. And if you are into malware development, you should know about the um, flaws and the different kinds of uh, bugs which exist within the Windows architecture. If I guess if you're not into that, it's not possible to explain all of that within a class of 1 to 2 hours. I guess even you would have to spend a lot of time to understand Windows architecture, bugs and vulnerabilities, and you have to write code to exploit such vulnerabilities. Okay, so okay, let's see how this works, and let's try it out. So what's the command for let's see, what's the command for uh, opening up a simple HTTPS server in Python from from a Windows machine? Any guesses?
Come again, sir.
What's the command for opening a simple HTTPS server or HTTP server from a machine using Python, so that I can host this directory on the network? Oh God. Oh God. Hello. Hello.
Small, you are audible.
Okay, I guess my virtual machine doesn't have Python installed. That's a new thing. Don't use virtual machines. Let me see if I can. Uh, okay, I need to uh, copy this agent to my Windows machine. Um, let me just install Python, I guess, a bit, and then I'll continue discussion on something else while this happens. Uh, so see, essentially, what we did was generated an agent in my Red Mimicry machine, and I downloaded that on my Windows machine, and I need to run that exploit in Windows 10. So,
Sir, no screen is visible. Hello, sir.
hello.
Yeah, the screen is not visible, sir.
Okay, okay. Let me see. See, I think I just turned off the screen right now, I guess, because setting up something.
Okay, sir. Okay, sir.
Setting up something. I'll turn back. I turn. Just something that's come on. So what we did was that we downloaded that thing on our machine and need to. You know any fast methods of transferring some file like from a virtual machine to a computer?
Like create a folder and just share it to the VM.
Yeah, I guess creating a shared folder would work, but I currently don't have a shared folder set up. Okay, so I'd show you what my agent does. Don't worry about that. Uh, but I really need to get this thing started. Okay. Um, I'd come back to the description of the agent, but let's understand something else till this thing gets set up. Um, let's understand some serious like coding aspects of malware. And I tell you how this is important, and it's related in to my previous thing of setting up an uh, like C2 framework and delivering exploits over such C2 frameworks. And I'd try to explain to you uh, how this is even relevant to malware development in a sense which perhaps you have not heard like before. So how many of you have like heard about shell codes or worked with shell codes ever, or you've had any idea of shell codes?
Shell scripting?
Huh?
You mean shell scripting, sir?
Yeah, shell not scripting like in the Linux shell, like not sh files, shell codes. You can see my screen now, right?
Yes, sir.
Okay. So what you see here, like I have a C program that's on the screen, right? I have a C program,
Yes.
right? So this is a standard C program. I guess C++ also has a similar structure, so I don't think that this would be much an issue. So what's this over here? What's this essentially? This is what we call a shellcode in malware development. And if you are into serious malware development in the future, you would need to understand a new type of coding where you can inject your exploits in the machine in a way that the antivirus would not essentially detect. So all of you have heard in theory that viruses inject code into the system, right? They inject code. That's the definition of viruses. But exactly how can one executable inject another executable in the machine, but the executable itself would not get detected doing that? Like if I write, if I have a malicious script and I compile it and I make it an executable, that becomes my virus. Now such viruses will have a code signature that's always readily understood by antiviruses, right? So how can we make an exe which would inject this virus into the system but itself cannot be detected as something inherently malicious? So how many of you are from the electronics and communication engineering background? How many of you from the ECE background? Anybody from the ECE background, or everybody is from CSE or like other streams here? Any?
CSE.
Okay.
I'm from EC, sir.
Yeah, I'm from.
ECE,
I'm.
right? So in ECE, you have heard about microcontroller and microprocessor programming, right?
Yeah, yes,
Yeah,
sir.
yeah.
Yeah. You have done 8085 or like programming on these kinds of processors, right?
Yes, 8051,
Yeah.
8085. Oh,
So I guess this code should make some sense to you. This thing over here. What do you do when you program on say 8051 or 8085? What essentially do you write the programs in? Do you write them in C? Does 80?
no.
You don't
We
write.
write opcodes for memory location.
Exactly. And look at that code. Look at that code. Doesn't it look like opcodes?
Yeah, it looks.
Exactly. And that's what shellcodes are. Shellcodes are position independent opcodes for your machine. They're written directly in assembly, so I can take, hello, I share this file with you, and I not essentially share this file with you. I show you where you can yourself get acquainted to shellcodes and what is there on the internet on shellcodes, and how you can discover this world of different kind of coding which is usually used a lot in exploit development to inject itself or inject codes into processes, run them stealthily, but not yourself get detected as a virus. So you're writing a naive C program with just uh, this kind of an array, and you're doing some basic pointer arithmetic over here, nothing that the antivirus would recognize as malicious usually. And now, since the antivirus can't exactly analyze these kinds of architectures readily, they can analyze, and right now you have to optimize on your architectures or your designs so that they can't. But these are not as readily understood by antiviruses as per se code signatures of viruses which are famous or which have been made by tools which are very known to us, like Metasploit. So what is this essentially, and how is this relevant to like coding your own malware? So has anyone heard about a course called SLAE, slay, by Vivek Ramachandran? Like, you heard the name Vivek Ramachandran in malware development or exploit development or anywhere else? Like, if you're not, then you're really missing out on something, because if you are going to code your own malware, I guess this place is a really nice place to start, and I'll show you. Uh, and I'll help you make sense of this program. Uh, but if you want to learn about shellcodes and if you want to explore shellcodes, then you can go to this website called shellstorm.org. This has a lot of like things or repositories for shellcodes. You don't find readily something that's here. You have to go to this thing called shellcode.org/shellcode. I would give these links when I upload this class on YouTube, so just really follow along with me. I'd give the links and everything over there. So this is essentially a repository for exploits. Um, let me open up the Linux section. This is ARM. This is what we need. We have Intel architecture machines. So look at the exploits now. Look at the things over here. Doesn't like this sound like exploits to you? A reverse shell, bind shell, shutdown, reading the PWD file, adding a user without a password, binding a TCP shell at a random port. You have heard, you have understood some of this when you are, you know, executing, like, understanding malwares per se. You have heard about reverse shells, right? Reverse shells in Metapeta, reverse shells, TCP, Metapeta, TCP reverse shells, right? They're essentially those modules which provide you command of the system. Okay, they provide you with, like, they provide you with an architecture to command these remote victims from your machine, and that thing is called a reverse shell. And if you have a reverse shell on somebody's machine, you can execute commands as that person from your machine, like as on that computer on your machine, and you can steal data and do everything. That's what Metasploit does essentially. So uh, we are going to analyze something different. We're going to analyze this. So right, this looks like opcodes, right? This looks completely like opcodes, right? This looks like opcodes. Push, pop.
It's
Okay, yeah,
Yeah.
Yes.
yeah, and
same as on Termex.
yeah. Well, come again?
As we have seen in the terminal now, sir.
Yeah.
SMS.
No,
This code code. Ah,
these are the
type of.
yeah, these are the direct assembly level languages, and for
Okay.
those assembly level languages, these are the shell codes. There are ways, like, you can see that this 6A42, that's what's here. It's push at this, and this is taken as 06A 0 like 0x6A 0x42. So whatever is coming over here essentially is just put as a stream over here, right? This is one representation of it. This is also a valid representation of a shellcode. And what it does is that it lets you get a shell or a command access by running a C program on the system. So usually, how do you open a Linux terminal? You open a terminal from your applications part, or you just put the keyboard shortcut for a terminal and a new terminal pops up. But what's the program for injecting a terminal? Like, what's the program for getting a terminal from a C file? What's how can we open a shell by executing a C file? Like, how can we open an application on a system without directly referring to that application ever? Because if you directly refer to that application, you are telling the antivirus that there's something malicious. So can you see anything related to shells or anything related to the Linux shell in the opcode? You can't, and the antivirus itself can't, because when I compile this directly gets into machine level format. So there's no middle layer of abstraction. So the antivirus cannot understand like a lot of it. So there's a compilation command given over here, and I have compiled this code, exactly this code. I've compiled it uh, over here, and I've saved it in a file called exec1. So what happens if we try out exec1? So see what happened. Any guesses? What happens when we run this program? We open a shell on my machine. We open the Linux terminal on my machine. Okay, so let's go with pwd. What does pwd output? What's the purpose of the command pwd?
Working directory, present
Present
working.
working directory. Yeah, present working directory. So if I enter pwd into a C program, what should happen? Like nothing, because I have not processed such inputs in my C program. But see what happens. This indicates that when I run the C program, what happened was that the C program somehow opened up a Linux terminal and gave me access to it. So think of this something like, if in this attacking scenario, if you want to steal data from somebody's computer, what do you need on that computer? You need nothing but a shell, right? You need a terminal to be open on that computer, and you need to access, you need to pass commands to the terminal and get data from the terminal, right? That's what you need when you are developing a virus like Metasploit, like even when you are developing a malware like Metasploit, right? This does have the job for you. You push these opcodes in your C program, get an executable, and when you run this executable on a machine, like on a Linux machine here, it would open up a shell. And now if you have a network connection which inputs commands to the shell, I'm inputting commands with my keyboard. You can also make shell codes to accept commands from TCP ports, push commands to this program, execute commands. So here you would get data back and forth from the system without the antivirus even knowing it, because the antivirus has checked the exec1 file, and the exec1 file does not directly contain anything suspicious. It just contains directly assembly level language arrays, and when these assembly level language arrays are like executed within the program during runtime, they give you access to system things, like they give you access to shells. So if you are making some malware or some implant which should give you a wireless access over to your machine, what should you be aiming at? In your program is going to just be a small bare bone program like this just the programs you have written, and it's going to be an array of shell codes. And all you need to do is take this program, compile this program, take this to your victim's machine, execute it. Instead of displaying the shell over here as an output of the program, you need to open it silently, and you just need to pass commands to this shell and get the output from this. Remember, this is not a terminal that the user has opened on choice. This has opened as a result of executing the program which the user thought was a normal C file, the normal compiled binary from a C file. There is no way that the user would have suspected that this would open up a terminal on the computer. This could be any naive thing, the and this provides a good lot of abstraction over the program. So the antivirus would not be able to analyze the entire like threat of it if it does not take the entire shell code and analyze the operation of these machine instructions on the machine. It's not as easy as detecting code signatures. You get that? Hello?
Yes, sir.
Yes,
Yeah,
sir. But
Mm.
yeah, it's not as easy as detecting code signatures. Now you have, it's just an array. So there are a number of ways to hide an array within a program. You can distribute them, you can put them in, say, like you can make special big strings where some specific, you can embed them using cryptography within those strings, decrypt them within a program, and just execute them using these kinds of commands, and you would get your access. What was the exploit here? It's just a piece of text, these lines of opcode that I have executed, and that has given me access over something like a Linux shell by just running this program. So it's a Linux shell in home/Ubuntu. That's the present like the place where I'm working, and whatever commands you execute from this shell will get executed on my machine in real time, and you can take the data, you can access data from it. So if you have used MSF Venom, try consider generating a shell code of your implant and inject that shell code with an exe. I would rather suggest that you go to this website and try out a lot of the stuff that's like, go to this website shellstorm.org shellcode. There's a lot of shellcodes that are there, that are ready programs for you to analyze and see what kind of operations these do. Try them out and try to make your own malwares by combining some of these features from the Shellstorm website, and you'd end up with some form of a malware that you can run directly from a computer, which is written in C, which is not that complex to understand. Okay, there are a lot of exploits over here for Linux. There for Windows, for Mac. So you see that the reach of shellcode is like, it's cross operating systems. It's Linux, Windows, Mac. So yeah, most of the time you will again be focused on Windows exploits. I'm just showing this on Linux because for the next part where I will teach you how to detect such programs, if you want to create advanced antiviruses for these, and where you want to analyze these kinds of structures. Um, just watch this. This is an obfuscated cell code for 32-bit and 64-bit machines, which download and execute using PowerShell generators. Like you can download and execute any program that, or any malware that you have hosted on the internet with these. When you embed these shellcodes within your Windows programs, these shellcodes have the capability of downloading stuff, executing stuff, putting out terminals, like taking in you understand that this has a lot of power, and coding this is not at all that complex. There are a lot of the Slay is definitely a good course on shellcode programming, and how you can understand or uh, like make your own shellcodes for exploits. There are there are shellcodes for a lot of stuff. There are shellcodes for automatically opening programs. Even if you want to add a local administrator, like you can you can literally add a user as an admin user to a Windows account. So you want to get, say, Windows access, like admin access to a machine. You want your antivirus not to detect it, and you do not want to go through the entire process of hacking this thing with like tools, or you don't want to hack into the original admin account. You can just use shellcode exploits, a lot of them, and do a lot of cool stuff. There have been some shellcodes for XP, you can see over here, and obviously XP is not something that you're going to use, but most of the shellcodes are operating like distributions of Windows free. They're going to run on everything from anything from like Windows 7, Windows 8, and there are a lot of shellcode experts for Windows 10. So you should consider going through this shellstorm.org and understanding the different kinds of exploits that you can do with shellcode, and try coding some of your own viruses and exploits. Uh, any questions? Any questions still?
No, nothing.
Okay. So let us for some time understand what what's the program that you have made, and how you can detect such operations if you are given a, say, exe, or if you're given something for disassembly and you want to detect if this is a malware, or how this would affect the system, and how would you recognize that there is a shellcode that's being executed within a like in a malware, and how you can prevent those kinds of attacks. So, how many of you have used GDB as a decompiling or a debugging device? GDB?
No, sir.
Okay.
C compiler.
Yeah.
Yes, sir.
We used to GCC.
Okay. This is a C compiler. This is a debugger per se.
Yes,
Okay.
sir. Yes, sir. That we have used
Okay. Mm, if you are into exploit development, or if you are into these kinds of local deployment applications, you also need to understand debugging. Okay, you need to understand that given an exe, how would you understand what the binary does, or what's happening inside the binary. If you want to write good exploits, you have to study like binaries of good exploits, and you have to come up with your own detection techniques for what's running, and how C programs, or like Windows binaries or Linux executables binaries, they are structured to function, and how to understand what's happening with a debugger. So yeah, I have a lot of stuff out here. I will give you all the commands which I have typed on this. I would provide all the commands in a text file when I like upload this on YouTube. You don't have to take the commands one by one. I'll explain what each command does. I've put everything out on the screen so that I don't have to write them again. So what the first line over here does, gdb q exec one, it opens up this binary into GDB in quiet mode. Okay, this just tells GDB that now it's time to disassemble this binary. And then what we have done is that we have set a breakpoint at main. That is, we have just told GDB that it's like uh, to analyze it like a program. So it's just easier. That's it. Uh, you just set a breakpoint over here, and we have set the disassembly flavor to Intel because my processor is Intel. I guess most of your processors are going to be Intel processors if you're not running on something like a like AMD processor on Raspberry Pi, I guess. So you just set the disassembly flavor to Intel, and right now you're going to analyze the code given over here. The thing that you should look out in these situations is this line. It's move EAX 0x0. This shows you that the shell code is being like loaded and executed within the program. Okay, this line would give it out to you, and why I've used this line is that remember the variable which I've used in this program. It's called SC. SC, right? SC. SC is the array. So SC is a symbol in this program which is understood by GDB, and I have written print SC, which provides the uh, address of SC rather. So if in an array everything you've heard this in yes a lot of programming lectures that in an array everything is stored in a serial fashion, right? It comes one by one in memory, right? If I have an array of say 1 2 3 4 5, the memory location of 1 2 3 4 5 would be side by side, right? And C
Yeah.
allocates memory like that. So if I have the starting point of an address of an array, what will the next bytes give me from that? It would give me the contents of this, right? So if I identify that there is a shellcode and I can find the address of the array which the shellcode is contained in, I can just print 23 congruent bytes from that starting address, which would reveal the contents of the array, right? Because all of these essentially just occupies one byte of memory. Okay, so it's a character. It's a unit 8 sign 32 character. It occupies one byte of memory. So you can see over here that I have printed uh, the 23 congruent bytes from the starting address, which I have got over here, and you can see 06A 0x42. Those are the things which I had in my shellcode, right? Those are the things which I have in my shellcode, right? I'm showing you once. 06A 0x42. So from here we understand that the machine has loaded these shellcodes in congruent memory locations one by one, and with this, when I execute the command, the entire array gets executed. You can see over here void star. I've just typecasted it as a pointer, and then I have just printed sort of like invoked sort of the array, and that's it. And what happened is that I tricked my machine to understand that SC was in fact a program. You understand that if a pointer is followed by this sign, what does it mean? It's a method, right? It's a method declaration, right? Open parenthesis and close parenthesis.
Yeah, yeah.
So just tricked my computer to understand that this is a function calling, and then and since these are incongruent places, when a function is defined, it's also defined in such a fashion, and the function is executed in the same fashion. So my computer just executed the malicious shell code in my program and gave me a pond shell on the machine which I can execute on. There are a lot of architectures which you have to understand when you are designing your own malwares. Essentially, you have to understand how programs work on a deeper level. You have to understand how stuff is loaded into the memory and how you can identify from a stack that, like, from a debugger, that what happens within a program and what variables and what kinds of architectures or function callings are used. Anyone has any past experience in debugging or making up like debugging programs or debugging viruses, like disassembling like compiled binaries?
No.
Um, yeah, so see, if you are going to develop your own malwares, you got to work on these kinds of skills. These are not skills that anybody can like teach you per se in a month or so. You have to develop these. You have to practice on these, and um, you have to develop debugging skills. You have to open compile binaries in debuggers like immunity debugger. I have used GDB over here because it's a command line tool and I really like it. I like like it's a command line tool. I'm not recommending GDB right away if you are not well into this debugging thing. You can use stuff like immunity debuggers or other very graphical interface debuggers to understand how an executable is loaded in memory and how an executable is run in memory. And I not lead you on to this, but I just may give you a hint that there are ways to generate shell codes like this for your metasploit exploit. Okay, that exe file you get when you run MSF Venom, or that exe file you get, which is a drop, which you drop on your Windows machine, and like we got an agent.exe, right? We got an agent.exe right away, and there are ways which you can convert exe files into shell codes either within the utility. Metasploit has an utility to directly output shell codes and not exe. So Metasploit would give you the shell code of its exploit, and you can embed this in your own malware and execute them. I would like encourage you to try this out. There's a lot of thing on the internet that you can look out for, and I'll add links specific to this problem of how to generate shell codes using Metasploit and how to use them in your, like, you can use them in your program like this. And then there's a tool called Donut. Donut also helps directly generate a shell code for any exe you give it. You have a exe for like opening up a calculator, you give Donut the exe as an input, and Donut will give you the shell code as an output. And there are a lot of ways you can experiment with shell code and write C programs which execute shell code and kind of make you make your arsenal wide, so that you have exploits which are undetectable by antiviruses mostly, and which have an elegant way of exploiting the system. We're not directly calling any functions or directly using vulnerabilities anywhere. In shellcode, it's about writing exploitable machine level languages, and there are some courses on how you can make your own shellcode for your own exploits if you come up with some, or I guess Shellstorm, or there are other shellcode repositories out there with lots and lots of lists for shellcodes and exploits based on shellcodes. I try to give links to these kinds of websites where you can look up shellcodes and regarding like topics regarding this, where you can develop on this very new and very well not so much known method of making malwares, which is elegant in many ways, and it's mostly undetected. It's not detected by antiviruses. Uh, um, so like you have used Metasploit before. I just wanted to show you a web panel for a C2 framework. I guess you all know how a normal virus or a post exploitation attack works, like Like you just take the exe, drop it in, then you get a like terminal out here, and then you can execute commands on that machine. That part, I guess, there's a lot of thing out there. It's quite well known. I'll still uh, let me see if I minimize this a bit. uh, I have some problem regarding transferring this. I guess you know a lot about these kinds of attacks, which I don't think post exploitation is something that's new, and I just wanted to show you a different type of post exploitation framework with the web panel. But general demonstration of post exploitation after this is kind of the same. Take the thing, drop it, and then execute commands on a shell which you get from your machine. You can do all kinds of stuff like get screenshots, get files. There are just a lot of documentation for it on the internet if you want to go up and read. But the most important takeaway I need like you to have is the concept of shell codes and how you can develop uh, like exploits using shell codes rather than using, you know, normal exe based programs. You can check this out. I'd give the link in the description, like of the video also. It's by the Hoover. It's called the program is called Donut. There's a lot of documentation on this on this thing. There's a lot of documentation on this, and I would tell you to go through it, and um, this will really help you to generate uh, custom shellcodes for exploits that you have perhaps written or you have obtained in an exe format for a Windows agent, and you can generate shellcodes directly using Donut, and then you can run them elegantly using C programs, and you can merge these kinds of exploits and make a better exploit, or you can uh, go on the internet and learn about how to make malicious shellcodes for exploits. A lot of them available on the internet. Study them, and I guess that should give you a good start to code your malwares in a different way, uh, quite different than the ones that are currently used on the internet using normal memory handling, memory like exploits, or modifying like custom DLLs on machine. Because whatever you do, if you do your thing directly from your C program, the antivirus will understand it and will stop malicious activity. If you inject your shellcode intelligently into processes which are running on the computer, there's a good chance that the antivirus will not understand it. And I guess this is a good thing also, because you can merge a lot of stuff out there without understanding a lot of code, and just understanding the machine level implementation of these exploits, which will give you a deeper insight into exploit development, and like encourage you to develop exploits in this kind of architecture. I guess that's about it. Hello.
Yes, sir.
Yes, sir.
So, Shmalo, are we done with today's lecture?
Yeah, we
It
are
was a
done.
great, man. It was great. It was the depth about, especially the shell coding part. It's great, and we would love to have you on board once again at some point.
Uh, Thank you. It's been my pleasure to attend this course.
Guys, do you have any questions?
No, sir. That
Sir, a little bit of red
shall.
mimicry because it's first time I'm listening this kind of server.
Okay, so if you want to understand red mimicry, I would rather direct you to understand this first. It's an open red mimicry is not exactly open source. The code is not available readily. So if even if I demonstrate it properly, you will not understand. You could go to this repository. I'd also add links to this repository in my description. It's called Covenant. It's a similar thing. It has a web panel like this. It has a web panel like this for the exploits, and you can try out web panel based post exploitation over here. It's really the same as Metasploit or local like shells type post exploitation frameworks. You have your list of compromised machines over here. You select one, and then you execute tasks on that compromised machine, just like what you do in MSF console. Exactly the same thing, but just clicking your mouse button rather than selecting it with select and set and all that. I guess I guess you have understood this. I really wanted to show it, but
Yes, sir.
I am having some technical difficulties with my virtual machine right now, so I can't demonstrate it. But I guess if you read through this documentation, it's very similar to what we get um, when we do Metasploit or other kinds of exploits. Just the web panel concept is new, and if you know about the WinNTI malware, you can obviously search a bit about WinNTI, WinINTI, like the malware which was there, and you can read about this thing. This was a famous Windows exploit back then, and this basically emulates that malware. And we also encourage you to, if you get some good exploit, then please develop such emulations, open source emulations, or like emulations for these kinds of thing, for corporate usage. Or this malware domain NTI, this was really famous, and this kind of an architecture for exploitation and privilege escalation, and if like basically red mimicry is like all about that. And it's exactly like MSF console, like Metasploit, just instead of a command shell, you have a web panel from where you execute commands. I just wanted to show you the difference of these kinds of post exploitation frameworks, and how and why rather a web based post exploitation framework would be better than a traditional CLI based framework. That's it.
Thank you, sir.
Any more questions? Any more questions?
Shell coding is a little bit confusing.
Yeah, shell codes would be confusing for someone, like anyone who is seeing them for the first time. It takes a lot of
Yes,
time
sir.
to. I just see here. I can't really like teach you the entirety of malware development within a 1 hour or two, like 1 hour course, right? It's not possible, and what you can do is I have just introduced you to techniques, or introduced you to red teaming and some detection techniques in this lecture. You can learn. I would provide links, and you can research
Yes.
about these kinds of stuff online, and you will find a lot of information regarding these, or from the websites I would give in the description. Shellstorm is a pretty good place to start, and there are a lot of other places where you can understand shellcode, and I would give some helpful links if you want to get started with shell coding.
Yes, sir.
But
Please attach those links.
yeah,
It will
but
really helps
whatever,
us.
like if you are really interested in shell coding and you really understand and master the art of shell coding, then SLA is a good course by Vivek Ramachandran. So like that course matches, like it's a very good course by Vivek Ramachandran, and you should, if you are that interested, you could take it, and you can understand shell coding in a very deeper perspective.
Yeah, sure, sir. In where the course is available?
Slay, I guess. I guess it's
Thank you, sir.
yeah,
So, Sumalu, can we
yeah.
call it
It's
end to the session today?
it's from Pentest Academy. It's from Pentester Academy. You should have learned about, like, have a idea about this site. This is the official name of the course, and yeah,
Pentest Academy.
yeah. You just Google SLA,
Yeah,
and
okay, sir.
that should come.
Yeah, sure.
It's from securitytube.net. If you're interested, guys, you can just visit this website and find it there.
That's the free
Sure,
video
sir.
Yeah,
version. Yeah, that's the free video version of it. You're gonna get a certificate, I guess, from securitytube.net, but you'll get a videos.
yeah, okay.
Okay, guys, so with this, we're closing the session for today. Thank you, Shamalya, for addressing such a wonderful lecture, and we'll be back with you guys tomorrow with a session on cryptography, I guess. So, see you all till then. Stay safe, guys.
Yeah. Thank you, sir.
Thank you, sir. See you.